Before we write a single line of code, let me show you what we're building. By the end of this lesson, you'll understand how applications like Spotify, Amazon, WhatsApp, and thousands of modern websites organize their data using JavaScript objects. We'll build the foundation of a real task manager, the same concepts you'll use later in React, Node.js, and full-stack applications. Let's create a new project. Inside VS Code, create a folder named Task Manager. Inside that folder, create 3 files, index.html, style.css, script.js. This is a simple setup, but it's the same structure professional developers use before adding frameworks like React or Vue. Now let's connect everything together. Imagine you're writing down a task on paper. You probably wouldn't write only its title. You'd also include whether it's completed, its priority, maybe even a due date. All of those pieces of information belong to the same task. JavaScript stores related information exactly like this, using an object. An object simply groups related data together. Whenever you're describing one real-world thing, a user, a product, a video, or a task, an object is usually the right choice. Let's create our first one. Inside script.js, let's create a variable called task. Instead of storing one value, this variable stores several related values inside an object. Each piece of information is called a property. On the left is the property's name, on the right is its value. Together, they completely describe one task. Let's print the object and see what JavaScript gives us. Printing the entire object is useful, but applications usually need one specific piece of information. For example, maybe we only want the task title, or whether it's completed. To access a property, we use dot notation. Think of the dot as saying, go inside this object and give me this property. This is one of the most common operations you'll perform in JavaScript. Real applications constantly update their data. When you finish a task, its status changes. Instead of creating a brand new object, we simply update one property. Watch what happens when we change completed from false to true. Objects are also flexible. If our application needs more information later, we can simply add another property. Let's add a due date. Now let's make a mistake that almost every JavaScript beginner makes. I'm going to misspell one property name. Can you spot the problem before running the code? We expected high, but JavaScript returned undefined. Notice that this isn't an error. JavaScript is simply saying, I looked for that property, but it doesn't exist. The property is named priority. We accidentally wrote priority. This tiny typo is enough to produce the wrong result. Professional developers don't guess when something goes wrong. They inspect the data first. Let's make our object a little more useful. Instead of printing each property separately, we can combine everything into one readable sentence using a template literal. This is much closer to how real applications prepare data before displaying it in the user interface. In just a few minutes, you've learned one of the most important concepts in JavaScript. You created an object, read its properties, updated existing information, added new information, and even debugged a common mistake using Chrome DevTools. These same skills are used every day in professional applications. So far, we've created a single task using a JavaScript object. That worked perfectly. But imagine if a real to-do app could only store one task. It would be almost useless, right? Real applications manage hundreds, thousands, or even millions of records. To store collections of related data, JavaScript gives us arrays. Let's upgrade our task manager. Since each task is already an object, building a list of tasks is surprisingly simple. Let's create a few sample tasks. We just place multiple task objects inside an array. This combination, an array of objects, is one of the most common data structures in JavaScript. You'll see it in APIs, databases, React applications, Node.js servers, and countless real-world projects. Think of the array as a bookshelf, and each object as one book on that shelf. The bookshelf keeps everything together, while each book contains its own information. Arrays use numbers called indexes to access their items. Unlike counting in everyday life, JavaScript starts at 0. That means the first item is index 0, the second is index 1, the third is index 2. This may feel unusual at first, but you'll quickly get used to it. Let's access a few tasks. Because each item is an object, we can combine array indexing with dot notation. Suppose we only want the title of the first task. Accessing one task is useful, but real applications usually need to display every task. Instead of writing the same code again and again, we let JavaScript repeat it using a loop. We'll use a for of loop because it's simple and easy to read. Notice that we wrote the code only once, but JavaScript ran it for every task inside the array. This same pattern powers product lists, playlists, chat messages, notifications, and social media feeds. Printing only the title works, but we can make our output much more informative. Let's display each task's title, priority, and completion status together. Applications constantly receive new information. When a user creates a new task, we don't replace the array, we simply add another object. JavaScript provides the push method for exactly that. I like using console.table because it's much easier to read collections than a regular console log. Many professional developers use it while debugging arrays. Let's make another common beginner mistake. Suppose we try to access the title directly from the array. Why didn't this work? Because tasks is an array. Arrays don't have a title property. Each object inside the array has its own title. The correct approach is to access an object first, then its property. Sometimes we don't need every task. We only need one specific task. JavaScript gives us the find method for this. Imagine searching for a customer by ID, a product by SKU, or a user by email. The idea is exactly the same. Now suppose we only want unfinished tasks. Instead of writing complicated loops, JavaScript provides the filter method. It creates a new array containing only the items that match a condition. Finding a task becomes even more useful when we update it. Let's mark the task with ID 2 as completed. This is exactly what happens when you click a checkbox in a real task manager. Here's a small engineering tip. Methods like find, filter, and loops are easy to read and are highly optimized by modern JavaScript engines. For most applications, writing clean and understandable code is far more important than trying to optimize too early. Measure performance first, then optimize only if it's actually needed. Here's a question that appears in many junior JavaScript interviews. What's the difference between an object and an array? A strong answer is, objects describe one thing using named properties. Arrays store multiple values in order. And in real applications, arrays often contain objects. If you can explain that confidently and demonstrate it with this task manager, you already have a professional understanding of one of JavaScript's most important fundamentals. So far, our task manager has one small problem. Our data works perfectly, but only inside the console. Real users never open Chrome DevTools to manage their tasks. They expect buttons, lists, interactive pages. Now we're going to connect our JavaScript data to the browser and build the first working version of our task manager. This is the same idea behind front-end frameworks like React and Vue. They take JavaScript data and display it on the screen. Let's build it ourselves first. Before JavaScript can display anything, we need a place for it. We'll also add a simple form so users can create new tasks. This structure is small, but it contains the same building blocks you'll find in much larger applications. A little styling makes our application much easier to read. We'll keep the design simple because today's focus is JavaScript, not CSS. Already, the project looks much more like a real application. Now let's connect it to our JavaScript. JavaScript needs a way to communicate with the page. We do that by selecting HTML elements. Think of this as giving JavaScript a reference to each part of the interface. Now comes one of the most important patterns in front-end development. We have data. We need to transform that data into HTML. We'll create a function called renderTasks. Every time our data changes, we'll simply call this function again. This idea powers countless JavaScript applications and frameworks. Notice something important. We never manually created 3 task cards. We created a system that can display any number of tasks. 3 tasks, 30 tasks, or 3,000 tasks. Let's allow users to add tasks from the interface. Instead of writing directly into the array ourselves, we'll create a reusable function. Notice how we're reusing the same concepts from earlier. Each new task is just another object. We simply place it into the array and render the updated list. Our task manager can create tasks. Now it needs to update them. We'll add a complete button to every task. When the user clicks it, we'll find the correct task using its ID, update the object, and render the page again. This pattern appears everywhere in front-end development. Let's break down what happened. First, we searched the array, then we updated the object. Finally, we rendered the interface again. Find, update, render. You'll use this pattern repeatedly in JavaScript frameworks like React. Every task manager also needs a way to remove tasks. Instead of searching for the task itself, we'll search for its position inside the array. For that, JavaScript provides find index. Once we know the position, we can remove it using splice. Notice that we didn't delete HTML directly. We removed the object from the array. Then we rendered the updated data. The interface is simply a reflection of our data. That's an incredibly important idea in modern front-end development. Our task manager is now becoming a real application. Users can create tasks, view tasks, mark tasks as completed, delete tasks, and every action updates the page automatically. All of this is powered by the same concepts we've been learning throughout this episode: objects, arrays, functions, loops, and the DOM. In the next part, we'll make this application even smarter by adding search, filters, empty states, debugging techniques, and a few professional improvements that will make the project feel much closer to a production application. Imagine having hundreds of tasks. Scrolling through them would be frustrating. Instead, we'll let users search by title. We'll add one input and filter our array before displaying it. Notice something important. We're not changing the original data. We're simply deciding which tasks to show. Many productivity apps let users switch between all tasks, pending tasks, and completed tasks. We'll build the same feature using one variable and another call to filter. What happens if no tasks match the search? Instead of showing a blank page, professional applications provide helpful feedback. Small details like this greatly improve the user experience. Take a moment to notice the pattern we've used throughout this project. Whenever something changes, we don't manually edit the HTML. Instead, we update our data. Then we call render tasks. The interface automatically reflects the latest data. This idea is called rendering, and it's one of the most important concepts in front-end development. Frameworks like React, Vue, and Angular all follow this same principle. They simply automate it for you. Let's test everything we've built. We'll create a task, mark it as completed, search for it, filter completed tasks, then delete it. Every feature works because we've built a solid data structure using objects and arrays. That's exactly how real applications are designed. Congratulations! In this lesson, you learned how to organize data with objects, store multiple objects in arrays, search and filter information, update application state, render data to the browser, build a real mini task manager. These aren't just beginner concepts. They're the same fundamentals you'll use in React, Node.js, APIs, and full-stack JavaScript development. Before moving on, I encourage you to improve this project on your own. Try adding due dates, categories, or task editing. Every new feature is another opportunity to practice. In the next episode, we'll explore JavaScript prototypes and classes, and you'll discover how JavaScript creates objects behind the scenes. Until then, keep practicing, keep building, and I'll see you in the next lesson.